Alright, this is the Unit 12 test review over radicals and exponential fractions, rational fractions. Okay, so on the first part here, notice that we're just converting. So if I'm converting, that means I'm going from a radical to an exponent, or I could be going from an exponent to a radical. Okay, so this one has a radical, so I'm going to go to an exponent. So the way you can remember it is crack and bottom. That number's in the crack. So it goes on the bottom. Done. Alright, on the next one here, I have a 3 right here. So what I can really kind of look at first, I know that's a cube root, and it's 64 a perfect cube. And it actually is. So here, I would do 2. The cube root of 64 is 4, so 2 times 4. And now I'm going to start taking care of all this. So x to the power of 5/3, and then y to the power of 6/3. Now, I can simplify that a little bit further. 2 times 4 is 8, times x to the power of 5/3, and then here, 6 divided by 3 is 2. Alright, on the next one, again, I'm converting. There's nothing there, so I know it's a 2, so it's a square root. Now, 50 is not a perfect square, so I'm going to have to break that down. So that gives me 25 and 2, and that gives me 5 and 5. So my groups are a size of 2. So I can pull out a 5, and then if I convert between the radical to the exponent with the variable, that gives me 9/2. Alright, on this one here, I've got the 3 on the outside, nothing I can do with it, so just put it right there. And then that gives me x to the power of 24/3, and that can be simplified a little bit more. 24 divided by 3 is 8. Okay, on this one here, you'll notice that I'm starting with an exponent. So if I'm starting with an exponent, that means I need to go to a radical. So I know I'm going to have a radical. The 7 will be on the inside. This number is on the bottom, so it goes in the crack. And then the 5 goes right there. So for instance, even like on this one here, I'm starting off with an exponent. So I know I'm going to have a radical. The q would go in the crack, and then the p would go there. Okay, down here I am simplifying. So here, if I'm simplifying, I'm looking for groups. So for instance, I got 6 m's. And I have 7 n's. Okay, and I can tell it's a cube root, so my groups are going to be 3. Now, first of all, I'm going to look at the negative 64. That is a perfect cube, so it's -4. And then I'm going to make my groups of 3. So I've got one group there and one group there, so 2 groups, so m squared. And then I've got one group here, so 2 groups, so n squared. But then I've got this one here that doesn't have a group, so it stays on the inside. Alright, on this one here, again, I am looking for groups. So I'm doing a cube root. I know 16 is on a perfect cube, so I'm going to have to break that down. So that gives me 4 and 4. 2 and 2 and 2 and 2. My groups are going to be sizes of 3. So there's one there, one group. So I'm going to have a 2 on the outside. Now I've got 7 n's, and I've got 12 m's. Okay, and I'm going to start making my groups. So there's one group, 2 group, so n squared. And then here, again, I've got 1, 2, 3, 4. So n to the 4th. And then I have this one left over right here. So it has to stay on the inside. And actually, I forgot something here. This 2 also didn't have a group, so it needs to go on the inside also. Okay, let's look at number 2 actually. So on number 10 here. On number 10, I'm dealing with a square root. So I know 16 is a perfect square, and I also have this 2 on the outside. So here I'm going to have 2 times 4 because 4 is the square root of 16. Now, I'm going to do this a short way instead of listing out all the m's and n's. So, here's what you need to ask yourself. How many groups of 2 can I pull out of 3? 1. And then you will have 1 left over. How many groups of 2 can I pull out of 8? That's 4, and none left over. And then how many groups of 2 can I pull out of 4? And again, that's 2. Now 2 times 4 is 8, so I have 8 times x times y to the 4th, z squared times the square root of x. Okay, on the bottom here, now notice here they want you to leave it in exponential form. So if they want you to leave this in exponential form, they want an exponent. So the rule is that when you're multiplying with the same base, so a 7, you are going to add the exponents. So that gives me 3 6 plus 1 6 equals 4 6, which reduces to 2/3. So 7 to the power of 2/3. Done. Notice, I did not multiply the 7 times 7. I left it the same. Alright, over here, my base is 36. So again, I'm not multiplying that. I'm just rewriting it. And that gives me 2/5 plus 9/5, which gives me 11/5. That can't be reduced anymore. So 11/5. Okay, so anytime you have a negative exponent, remember all you do is you flip it and you move it either to the top or the bottom. So this one's on the bottom, so I'm going to move it to the top. And once I move that to the top, this one on the bottom is no longer here. This is now gone. Okay, so now I'm just going to start reducing it. Both of these can be reduced by 4. So if actually the largest thing can be reduced by is 8. So 24 divided by 8 is 3. And 16 divided by 8 is 2. And now I'm going to start dealing with all the exponents. So I've got 6 here and 1 here, so I have more on the top. And I have 5 more. All my y's are now at the top, so y to the 13th, because I add them. And there's my answer. Okay, on the back. Okay, so here's where we're actually starting to solve. And you really need to check for your extraneous solution. So it's best to probably just use the calculator there, or you could do substitution. So on this one here, I have a radical. So in order to get rid of this square root, I'm going to have to square it. Well, if I square one side, I have to balance it, so I have to square the other. Okay? So now what I have is I have x plus 12 equals x squared. Now, because I'm dealing with a quadratic, a squared, I have to make this whole thing equal 0. So I'm going to move everything to the other side. So that gives me 0 equals x squared minus x minus 12. If I factor that, I get x minus 4, x plus 3. So x equals 4, and x equals negative 3. Now, this is where I want to check my answer, because one of these, it could be extraneous. So I am going to go to y equals my calculator, and I'm going to type in the square root of x plus 12, and I'm going to put an x right here. Okay, 4 is definitely an answer, because y1, y2 match, so that's an answer. So that's good. And now I'm going to check the negative 3. And you'll notice that these are opposites. So because those are opposites of each other, this is my extraneous solution. So x equals 4 is my only real solution there. Okay, on number 17, again, I've got radicals, or square roots. So in order to get rid of a square root, I'm going to square it. And once I square it, I just have 8x plus 3 equals x plus 17. And then I'm just going to start moving stuff. So minus x. That gives me 7x plus 3 equals 17. Minus 3. That gives me 7x equals 14. Divided by 7, x equals 2. And again, I can check this answer. So I'm going to come over here. And if I check it, I'm going to have 8x plus 3 and then I'm going to have x plus 17. And if I check my answer, x was 2, and that is correct, because both of those are the same. Even though they look a little wonkier than what we're used to, they're still the same, so that's good. Okay. All right, let's look at number 19. Okay, so on number 19, you have one extra step you have to do here. So this 2 is being multiplied by that, so I've got to divide by it. So that gives me x plus 3 equals negative 6. Now, I also have this cube here, this cube root. So in order to get rid of a cube root, I cube it, and whatever I do on one side, I do the other. So this gives me negative 216 equals x plus 3. And to solve it, I'm just going to minus 3, and x equals negative 219. Alright, so I'm going to check this one by substitution. So I'm going to come over here, and I'm going to do 2 times the cube root of negative 219 plus 3. And if everything works out, well, I should get negative 12. And there it is. So my answer is correct. Alright, on this one here, again, I have an extra step I need to do. So I've got a negative 7, so I'm going to add 7. Add 7. That gives me the square root of 6 plus x equals 5. And then I'm going to square it, and then I'm going to square it. So that gives me 6 plus x equals 25. Then minus 6 minus 6, x equals 19. And again, you can check it. So you could check it into y equals, or you could just substitute it in. I'll substitute this one in. So 6 plus 19, make sure I'm out of the radical, and then minus 7. And if I did everything correctly, I should get negative 2. And there it is, negative 2. Okay, on 22 here, I am going to again be solving. So I'm going to divide by 5, divide by 5. That gives me x to the power of 3 over 2 equals 8. And in order to get rid of that 3 over 2, I flip it and put to the power of 2/3. Well, if I put one side to the power of 2/3, I have to put the other side to the power of 2/3. And when I put 8 to the power of 2/3 in my calculator, I get 4. So x equals 4 here. And again, I could even check this one. I mean, you can really check every single one. So like, let's say I just go to this y equals for this one. So 5x to the power of 3 divided by 2. And down here I'll put 40. Now we got 4, so I'm going to go check 4. And there it is. It matches. Okay, let me go back up to 18. Alright, so on 18 here, again, I got to square this, which means I have to square this. So that gives me x plus 3 equals, and then notice here, this is x plus 1 squared. So I actually need to do x plus 1 times x plus 1. And when I do that, I have to FOIL, so that gives me x squared. That gives me 1x. That gives me 1x. And that gives me a 1. So that gives me x squared plus 2x plus 1. And then I'm going to move everything over, because again I have a quadratic. So I'm going to do a minus x, minus 3, minus 3. Alright, so that gives me 0 equals x squared plus x minus 2. That gives me x plus 2, then x minus 1. So x equals negative 2, and x equals 1. Now, again, I need to check for extraneous solutions. So I'm going to put both of them in the calculator. So that gives me the square root of x plus 3. And down here I'm going to have x plus 1. And this is an extraneous solution, because again, these are opposites. So this is my extraneous. I'm going to abbreviate that. Okay, so that's my extraneous, but now let me check 1. Yep, I can tell it works. There it is. And so 1, both of those are the same. So this is my real answer. This is like the real one. Okay. Alright, so on 25, all we're doing is we're simplifying there. So again, there's a 3 there. So anytime you have just a number, remember there's a 1 there. Now, I can also remember I'm doing a cube root. So really what I have here is I have 7 times 16 to the power of 1/3. Now you could just put that 16 to the power of 1/3 in your calculator. But it came out all wonky. So that tells me I'm going to have to take that 16 and I'm going to have to break it down. Now, because it's a cube root, I'm making groups of 3, so there's the 2 right there. So 7 times 2, and then I'm also going to have a 2 on the inside. So that gives me 14 times the square root of 2. All right, here's the last one. Okay, here I'm doing a square root. Now, I know 76 is not a perfect square, so I need to break that one down. Okay, so if I break this one down, again, I'm doing a square root. So this one's a little different. So I have this 3 on the outside. I also have a group of 2 here, so I've got to multiply that. And then I also have a group of 2 here, so I have to also multiply that. But then notice that this is kind of left there, so that's what goes on the inside. So out here, if I multiply all that, I get 18 times the square root of 2. Okay, I hope this helped you. If you have any questions, make sure you talk to your teacher for extra help.